Okay, this is really great to have the opportunity to be here with you today to present the work of the whole SUHO team. I will be speaking about the design of the 10-star house, which has been a project that was really important for us to demonstrate that we really want to drive Australia sustainability in the construction. And so here we are. I hope you're all safe and well, and that you will enjoy the half an hour that will follow. So this project that I will speak about today is actually the result of a competition that has been done by SUHO through the BDAF challenge, the 10-star BDAF challenge. And so the project of the 10-star design in SUHO has won the competition. And Jim Woolcock decided to take the opportunity to actually build the house. So it was this land in the eastern suburb of Adelaide in Woodford. And gave us the opportunity to work on this project. Once to demonstrate what a 10-star house is, because this is one of the first projects in South Australia, if not the first one, and also to give the business the opportunity to use all this knowledge in-house, and also to prepare the transition and be ready to build really energy-efficient houses. So it's not just a house, it's a pilot project. So this is a project that has given the opportunity for the business to work on some really interesting and innovative solution, for some partner to collaborate and show projects that go toward a better sustainable built environment, and also to be able to prepare the construction industry to shift into a new type of construction. So one of the first aspects that we went through is to reduce the footprint, and the land is small, so I will explain in the next slide how it is important to actually consider the space we use to do so, and also to reduce for sure the carbon emission, and on top of everything, and it's quite important to provide a healthy and comfortable environment. So this is a 10-star house. So as I mentioned before, it's a small house on a small land, but we didn't want to compromise with architectural quality too, so it looked pretty. So if I go back on the fact that we decided to reduce the footprint, the work that has been done around this project is coming into a context of urban design for transitional cities. And here you can see the principles of better street and better cities that have been introduced into the design for years now, when the idea is to actually give a better density to the city, but also a quality of it, and give the opportunity for people to live and connect together in short distances. So this is about changing the way we move. This is giving the opportunity to use more bicycles, to walk more, to connect with people, to have a more fluent transit, and also to densify, to save the land. I mean by that the agricultural land that gives us the opportunity to feed ourselves, but also the natural environment. And so this is about shifting for something different, where, for example, the car will have less space, or at least if it uses some petrol and non-renewable energy, for example. So if we look at the history of the construction in Australia and the size of the houses, study has been done to give us an average of the size of the homes in different countries, and we can see that Australia, with an average size of 214 square meters, is pretty a bad child in the history and in the world conception of using space for families. Two of the main reasons are that the land is big, and I think there is no pressure need for reducing the size of the houses, but also because of the climate and the fact that there were not so much importance given to actually control the temperature inside of the houses. So we can see that places like Hong Kong that has a really high densities, or countries like Denmark where there is quite extreme weather condition, have a small footprint for the houses. So the question is, how much space do we need to actually live in, and do we need to be big to live big? So here is a situation of the project. So it's on Glen Stuart Road in Woodford, on the development area, and the land is actually 310 square meters, which is pretty small. This is actually an affordable land at the moment, and what is really important in this project is to consider that we will deliver in the future houses that are energy efficient for a big part of the population. So we need to work with the constraints of small land that are affordable for most of the people, and so they can really imagine this kind of project achievable. So how much space do we need? So the 10-star house is actually only 116 square meters, and on the small land, like I mentioned before, and there is 3 bedrooms. If you look at the plan, we've really worked on the accessibility of the house, and we didn't want to sacrifice at all the healthy aspect of it, the affordable aspect, but also the comfortable aspect of it. So this is about giving the opportunity to imagine a typology that is quite different, where even if we work with a small surface area, we make it really, really efficient in terms of functionality, and we use every space. So this house has a lot of transitional space, so we try to reduce the idea of a corridor, introducing like laundries in the walking area, and then having the nook enlarged at some point, opening on a larger living area. So every space is used, there is a lot of storage, and there is a real relation in between outdoor and indoor that give us the opportunity to extend the space of the house outside. So having a smaller house, it's a new lifestyle also. It's less to pay for, it's less to warm and cool, so it's, in terms of energy saving, it's really important. But there's also less to clean and to worry about, so it's more time to enjoy life, and then we shift the value of what is important to do with what we've got. This is also about reducing the carbon emission, and I think working in the construction industry, we need to be really aware that this industry is actually giving a lot of impact on the environment. And if you consider like the production of energy for residential use plus the energy consumption in the construction of dwellings, as well as the whole industry to make all these materials, then we realize that the construction industry is like half of the carbon CO2 emission in the world. So there is a real concern about that, and I think it's like necessary that we consciously work toward a different way to to impact the emission of CO2. So one of these aspects is we work toward clean sites and try to reduce wastage on site, and also the way we work with the trades, so everything is recycled, and there is we're conscious about chemical use and what we do with the waste of it. But it is also, as mentioned before, to reduce the surface area. And after all, and I will speak about that later, a really important point is to use less energy to service the building. So when I spoke about clean sites, for this project we had the opportunity to work with SCASAP that offer a toolbox for the trades, so we could really put the maximum of opportunity on our side to create a clean site. And so using this toolbox and watching what the recycle of the material on site has been, we had the information that more than 97% of the material that has been used on site and not put in the construction were recycled, which is a really good result for us. I think there is a lot that can be done with that, as well as introducing the prefabricated system so we don't have so much waste on site. Now let's go back to the 10-star and what the 10-star challenge is, as it's a challenge, but it's also a really great journey. If we look at the average star rating of the house in South Australia, we're at 5.4, I think, at the moment. And the objective of the regulation is to go into the 6-star rating for houses as a minimum required for construction. Now 10-star is well over that in terms of objective, and if you look at the consumption of a 6-star house, it's like 96 megajoules square meters per year, when a 10-star house, which is basically nearly passive, is 3 megajoules square meters per year. So that has required thick insulation in the roof and in the wall, as you can guess. But it's also a more complex way to design that brought us into that, and I will explain it later. So what does that mean? If we've got 3 megajoule square meters, 1 for heating and 2 for cooling, it means that most of the hours in the year, and you can see it on the graph on the left side, are actually in an average temperature of 22 degrees. So if we take this house without cooling and heating system, we can realize that there is a really small amount of hours in the year where it actually requires some energy to be put to be in a comfortable range of temperature. And you can see on the graph on the right side that the bedroom temperature all the year long is turning around 20 degrees, in between 19 and 20, which is really, really comfortable. And the other bedroom, as you can see, is lower, so depends on the position in the house for sure. But if you compare to the house, the temperature is pretty good. So how do we design a house that is a 10-star house? This is a process that is quite complex, I have to say, and requires some knowledge into solar passive design, but also many different strategies in terms of how do we build the envelope and how we work with the insulation and make sure that it's also safe for the building, which kind of windows we use, but also how do we produce energy. And so in this work that we've done, we went beyond the 10-star requirement to make sure that all the aspects was actually taken in consideration, as we are really conscious that any certification system has its limits, and that after all we need to work with the reality. So we've been working on what we call a smart envelope, and also delivering healthy and sustainable choice into the material and the energy production. So one of the first principles that has been used, and that is really important in terms of creating a passive house, is to actually use passive design. So I will not go through the whole system of passive design. I mean, probably could do a whole webinar on it, but there is many aspects that are considered to actually make a house with a better passive design, and one of them is to actually design the living area and the bedroom and service area toward with a sense of orientation. So this is the north, like you can see the north. It's pretty clear on the drawing. All the living area are actually facing north in this building, and then you can see that the bedroom are southwest and southeast. So to be able to check also how the sun is working with the house, we've been simulating the building and the shading all year long. So you can see on the right side that in June, in the middle of winter, there is quite a lot of light coming into the building, when the same time in the equinox of summer, there is pretty much nothing coming in, and this allows us to regulate the temperature in a big way in the house as well as the mass in the building. So we've been using shading, so there is a pergola outside with deciduous plants, and the size of the overhang of the roof are really important. We also work with outside shadings like Venetians, to be able to actually stop the effect of the sun on the glass before it's reached, which we find out is a lot more efficient. So all of it is going into an idea about controlling also the orientation aspect. And another aspect that is really important that we've been working on is actually the thermal mass. So 52 cubic meter of brick and 305 cubic meter of concrete slab into the building, a dark concrete slab, so we can actually work with the emissivity of the material. So PGH has delivered on this project all the brick, and we use them as feature as well as sometimes render them to obtain a really nice architectural effect about it. So this is about like using the mass to actually keep it cool in summer by having the material delivering freshness all the day long, and actually warming up the house when the sun can heat the mass in winter. The strategy about energy is really important. We made a strong choice of having everything electric, which we think is really important nowadays. We don't want to use fossil fuel and energy, so this is for us a starting point to consider everything electric. So we can lower the consumption by using some LED for sure and a rated appliance, and the system is pretty good in terms of star rating for that nowadays. And we use also some heat pump and HRV system that require a really small amount of energy to be run. So there is a production of 5 kilowatt solar panel, which is kind of a basic solar production for a building, but as we double the strategy by using less energy with the appliance and require not so much energy used to warm up and cool down the house, added to some reactor inverter and batteries that will actually cover the use of the house mainly. So we've got like 3 set of reactor batteries that ABB has delivered, and we also had a car charger for electrical car, because we look in the future with this project, and this is what we want to see, is electrical cars everywhere. So the water conservation of the project has been considered too. There is a tank in the back. A second one has been planned and not installed, but the idea is to, depends on the site and the size we've got, to actually supply maximum water to be able to connect to the toilet, the laundry. And so Stibel offer also some filters to be able to use the water on site. So PV panel that Tindo Solar deliver for this project, and the battery, the water filter, and the heat pump that has been delivered by, as well as the HRV by Stable. So this is all our partner that work with us to help us deliver this really high quality standard of house. Now I will speak really quickly because I think I need to hurry up about the smart envelope and show you that this is actually a big thought has been done to organize the wall construction and the roof construction to be able to achieve this high value. So in the roof we've got smart joists that are filled with superfill carbon plus blowing insulation, which is an interesting product because it's actually product made of recycled plastic. So and this way we could achieve R9 in the roof added to anti-con blanket on top, just under the color bond steel roof. So it's really interesting to see too that we had a thought about the ventilation in the roof and the ventilation in the walls that help also to work with efficiency. So it's a reverse construction as you saw before. So we've got reflective layers to work toward the mass, and insulation on a basic 90 mm stud with outside insulation with a Kingspan product called Cooltherm K12 that allow us to reduce also thermal bridging. So one of the aspects that we work on, and one of the reason we did that is that we use energy recovery ventilation system, is that we work toward airtightness, and this is by what you can see is like one of the methods we use to work with airtightness is basically the red pen light. Jess, my colleague, is giving some webinars around airtightness subject, and I really recommend that you have a look at it if you're interested, because you will understand a bit better what it is about. I will not go too far on this subject today. So good insulation, no thermal bridges, really important. Triple glazing and thermal broken frame. That's about the windows too that are part of the smart envelope we're working on. So what we want is a healthy building, and as we put more insulation in the wall and in the roof, it's important for us to consider the way we decide to make this building airtight or not. When there is a contrast of temperature on a surface area, there is a high risk of condensation, and this is due to lack of insulation and thermal bridging, but also to the lack of airtightness where there is air infiltration in. So we decided to really work with the airtightness too in this building, and the first test that has been run at the end of the first week was really really satisfying. So we obtained a 0.62 air exchange in the building, which is really promising. And this, to be able to work that out, first we have some amazing trade on site, but we also have really competent people working with airtightness within SUHO. And one of the strategy has been to work toward the detail with these elements. So yeah, the building has been, like the Kingspan board has been taped for outside, and we organize service layers in the roof, in the ceilings, and in the walls to be able not to interact too much with the airtight layers of the walls. By controlling the airtightness of the building and having a really airtight building, we made the decision also and to ventilate the building, so using a heat recovery ventilation system. This way we can supply fresh air full of oxygen all the year long in the building if the users are not opening the windows. There is the software, the star rating software, is actually using average users to be able to simulate the use of the building. But as we know there is no average person, so no average users. You feel safer in such a well airtight and well insulated building to be able to have a mechanic ventilation that is actually supplying fresh air. So that's what happened. And because the building is airtight, it's actually used to its best efficiency. So Stibel Elton delivered this for the project, and it has been installed by Adelaide Geo Exchange. So we also use some sustainable material, sustainable source, wood, hardwood and timber, and also plasterboard that are green rated thanks to Knopf gyps. And we give a special care to use non-toxic component, low VOC paint and timber treatment, as well as consolidated brass tapware. So we have no chrome in the finish of the tapware, so it's a lot healthier. So we went beyond the 10-star requirement, as you can see, and we also introduced ABB product, which is called ABB Free at Home, to be able to have home automation set up in the project. So basically, the ABB system is actually controlling the outside shading, the Venetian blinds, and the opening of the top windows, the lighting, and we've got a lot of overview on the system, like the hot water system and everything. So the users can have a real-time information about the energy use and where it goes. And also it gave us the opportunity to plug another system that Smart Automation has designed to be able to monitor the house and have some feedback about all the work that has been done. So yeah, that's what has been done in the last year by SUHO, and here is the building. I put this slide because I think we're really proud to have demonstrated to that it is possible to build sustainable building in a really standard situation and still give a lot of care to aesthetical finish. And thanks to the Woolcock group that has been built the 10-star house, we've got a home that is not only clever and energy efficient and sustainable, but also pretty. And yes, you will have some more information and more detail about technical aspect of the construction if you keep following our webinars, because some more are coming. As I mentioned before, there is a SD consultant in this company and specialist and about airtightness. And so if you want more information about particular subject, you can still keep an eye on our website and be informed about the next webinar coming. And the 10-star hopefully will be visited soon, as the site is nearly finished and when everyone will be safe to go outside. Thank you for your attention. I will try to check on some question that has been asked there. There is a lot. So yes, the north orientation was at the top of the screen. So basically all the living area, Richard, are facing north. So yes, the residential project in this case has been done into the NCC, not towards a new NCC, even if we actually work now with the new norms, as we've got specialists able to speak about it here. Yes, so Richard, there is monitoring being done on the building, and they will be in the 2 next years. So we will give us some feedback to speak about the rating and all sorts of elements that we're really happy to have feedback on, as to be able to be comparing the simulation of the building with the reality of it, and also where the energy consumption is going into the building, so we can really work with elements and go toward more innovation, and it will also allow us to actually, because we're working also on 7 and 8 star and cost-saving solution, to be able to introduce some more thought into the work that will be done in the future, even if we have a lot of experience already with this one. So yeah, the Tinder panels have been installed in the roof. They tilt toward north, and there is 5 kilowatt on the roof, and it's connected to the 3 batteries and an inverters. This production of energy is really primordial. So the house is, despite the fact that it's not completely off grid, is potentially really close to. And it wouldn't require a lot more to be actually having the house completely dependent of the grid, everything being electrical. So the Tinto delivered this project as a partner for the 10 star, and we're really happy to work with this company that is actually a local company and delivering a high quality product. So Ruth is asking me to speak about the rating software and the work that we've done back and forth. We actually, the 10-star design has been done really in consideration with the software results. So basically the software is a parametric element for the design of the 10-star. And so going from the best way to answer the software requirement, we took the plan and worked out an architectural quality and typology for a dwelling. So really, this is the base of the work. Now, in terms of construction, there is not a lot of aspects of construction that are parametric in the software, and it basically go back to the BCA, which is, in terms of sustainability, still, as probably you know, still a bit light. So we've been working with some knowledge brought from overseas, and some engineer thought about how it can be done. And the work that has been done on site with the construction brought a lot more than the expectation of the software in terms of construction. The reason why we did that is we have in the idea that the simulation is not the only thing that acts on the performance of a building. So there is a lot of work that needs to be done with builders, so everyone is really aware of how everything on site impacts the performance of the building, and the wood construction has been really a good ally to work with that. Yes, it is a typical family in the construction. Thank you very much. We'll be here to present you some more of our work and explain small details of the process, go back on the detail in construction and what's happened on site with a company we've been working for. Thanks to our partner that gave us the opportunity through their participation to actually make this beautiful project happen, and being such a great quality. and I hope we see you soon, and can give you some more information and have more feedback from you.